We're just a few short days away from Starship's 6th test flight, and this is going to be the last flight of the first generation of ships to fly. This will also be the 4th and likely final Starship launch of the year, but SpaceX has plans for a lot more launches in the near future. We'll be taking a short trip down memory lane and look at the rough road to get Starship where it is right now, what's new during Flight 6, and why all of this is important for what's coming up in the next few flights. So let's get started. It seems like ancient history, but Starhopper's flight test campaign was only 5.5 years ago. And just this month is the 5-year anniversary of Mark 1 failing its cryogenic proof test. Remember when even just building Starship's stainless steel tanks and getting them to hold cryogenics seemed impossible? And that was not the end of that. SpaceX also suffered several issues as it made its way to full ships, such as the SN3 crumple pop and the SN4 explosion after a static fire test. Even when SpaceX finally got to the first full ship, which was SN8 as a reminder, it still suffered issues during testing, and SpaceX found out that it was not as easy as it seemed to ready these vehicles for flight. That being said, Starship's low-altitude flight test campaign demonstrated for the first time that something as crazy as the belly flop landing profile could work, even though it took 3 to 5 attempts, depending on who you ask. After a whole bunch of toil with ships, then came time to build a Super Heavy, as SpaceX was ready to start getting into full stack missions from here in Starbase. Needless to say, this was a painful period in Starship's development. Elon and other SpaceX officials said multiple times back in the day that they were mere months away from Starship finally flying in a full stack configuration. I mean, it sounded kind of believable at the time. Every few months there would be some new big milestone that would make it seem even more possible. Remember when SpaceX fully stacked a Starship just by using a giant crane? In retrospect, this now seems like completely janky and not even close to being able to launch a Starship, as look at the tower now with the chopsticks and everything else. But back then, this was a huge milestone. Those that were there, like me, were ecstatic about finally seeing a full stack Starship. But those two vehicles, Booster 4 and Ship 20, were not the ones that eventually flew. In fact, Booster 4 never even got to engine testing on the orbital launch mount because neither the launch mount or the vehicle were capable or suitable for said testing at the time. The launch pad was one of the big contributors to the delays, leading to the now famous "work continues on the orbital launch mount" joke. It took nearly a year of work after that full stack for the pad to be ready for engine testing. By then, SpaceX had already moved on to Booster 7 and Ship 24, and when they finally got to test engines on the booster, well, SpaceX learned once again that you really don't want clouds of methane and oxygen mixing all willy-nilly. Thankfully, SpaceX recovered quickly and went full steam ahead with the testing of both vehicles that were to finally be used on Starship's first flight. 20 long months after that first full stack with the crane, Starship finally flew into the skies, and so did a bunch of concrete and sand from beneath the launch pad. While SpaceX had learned a ton so far and tested both vehicles a whole bunch, they surely did not foresee that the concrete under the pad would fail this catastrophically. In retrospect, the flight itself was also kind of a mess. While Starship didn't immediately fall to the ground, it did lose control about a minute into flight, along with a whole bunch of engines, as leaks and fires started in its engine bay led to its final demise. Even the vehicle's flight termination system did not work on this flight, which only ended when the aerodynamic forces ripped the stack apart. As Das put it perfectly, it did a Kerbal.
Did it just do a Kerbal?
But it wasn't all gloom and doom. The silver lining of that flight was that finally SpaceX had actual flight data of a full stack Starship. With that data, SpaceX could improve the chances of success on future flights, and boy did they ever. Teams worked astonishingly quickly to upgrade the launch pad with reinforced foundations and a massive water-cooled steel plate and deluge system underneath the pad. This would hopefully make sure that no more craters were dug into the ground during Super Heavy ignition on Flight 2. The Super Heavy for Flight 2, Booster 9, was also upgraded with new electric thrust vector controls on its engines and a fire suppression system and better structures. This meant that when Flight 2 came around, even though the wait was rather long, it was all worth it. For the first time, all 33 Raptor engines on Super Heavy lit up, and we finally got to see the mega Mach diamonds on Starship's exhaust plume. SpaceX also added a new way of separating the stages, which is hot staging, where the ship's engines start up while the booster is still thrusting and connected to it. While on Flight 2, SpaceX achieved some huge successes, the flight still fell short of completing a full flight profile as intended. The booster broke up a few seconds after it started its boost back burn, and the ship for this flight, Ship 25, also suffered from fires in its engine section and was eventually lost before reaching its intended trajectory. By the way, if Flight 6 does happen on November 18th as currently planned, that will be exactly 1 year after Flight 2. SpaceX came a lot closer to full success on the third flight of Starship in March of this year. It was the first flight where both booster and ship had a completely successful ascent. It was also very ambitious, with lots of different test objectives for the ship on this mission. That's Ship 28. These tests included actuation of the ship's payload bay door, that means opening and closing it, an in-space relight of one of the vehicle's Raptor engines, an in-space transfer of cryogenic propellants, and testing of the ship's heat shield during re-entry. Oh, and on top of that, SpaceX also changed where the ship was going to land. On Flights 1 and 2, they were targeting a splashdown in the Pacific Ocean, which they never got to do. For Flight 3, they changed the splashdown location to the Indian Ocean. However, once again, more issues appeared on this mission. The booster, Booster 10, was lost during its attempted landing burn over the Gulf of Mexico. The ship also lost control while in the coast phase and did not meet the needed conditions to do the relight test in space. These two, as well as Booster 9's demise, were later confirmed to have had a common source of failure, which was blockage of oxidizer inlets to the engines due to ice buildup inside the tank. This ice also blocked vents on the tank, which are used on the ship for attitude control, eventually causing it to lose attitude control. However, it's silver lining time again. The ship did successfully test the transfer of liquid oxygen from its header tank into its main tank in 0G, which probably gave SpaceX a lot of data on how to handle that in the future for orbital refilling. But having lost control, the vehicle was not able to remain stable enough for entry, and it was lost. It wasn't until Starship Flight 4 when one could truly say that the mission was a full success with no asterisks, caveats, or anything else like that. Both Booster 11 and Ship 29, the vehicles flying on that mission, successfully completed their ascent and descent profiles, successfully splashing down in the Gulf of Mexico and the Indian Ocean respectively at the end of their flights. Of course, things didn't go 100% perfect, but it was certainly a huge improvement over the previous 3 flights. While Booster 11 lost an engine on the way up and then another during its landing burn, it still landed with enough precision that SpaceX decided no more water landings were needed and that they were finally ready to return a booster back to the launch site to be caught by the chopsticks. In the case of Ship 29, this time around, as compared to Flight 3, there would not be that many test objectives during the coast phase as there were with Ship 28. It would just go up into space and attempt a re-entry. But for the first time, it would also attempt to perform a landing burn in the Indian Ocean. Up until then, the plan was for ships to just crash against the water at terminal velocity and deal with landing burns later down the road. I guess Flight 4 was already down the road enough to try it out. The re-entry of Ship 29 was super nerve-wracking to say the least. No less thanks to the live views provided via Starlink that SpaceX shared with us for as long as they kept signal with the vehicle. While the ship demonstrated that it had stable control of its attitude and that the flaps worked to steer it through re-entry, the heat and plasma building up around the vehicle were quickly becoming a concern. As it turns out, the plasma ended up eating through the gap between at least one of the forward flaps and the body of the vehicle, damaging it substantially. Despite that, somehow, the ship survived re-entry and was capable of performing its flip and landing burn successfully. The first time since SN-15's landing in May of 2021. But the landing did not happen exactly on target. The damaged flap prevented Ship 29 from guiding itself with precision to the landing zone, which it missed by a mere 6 kilometers. Still not bad for the first ship landing attempt from an orbital velocity. So now we get to the previous flight, Flight 5. It's become a joke by now, but of course, they caught a booster! While Flight 5 was largely similar to Flight 4, this time it included the all-important booster catch. In order to prepare for this, SpaceX spent the better part of the summer upgrading the chopstick arms and performing a slew of tests on them to make sure that they were ready to go. Part of these upgrades involved installing lots of reinforcements on the major weld lines of the arms. This would give them extra strength and hopefully make it so that they could be able to support a lot more load during a booster landing. SpaceX also installed reinforcements on the carriage system and the tower as well, so they could handle both the movement of the chopsticks and having to suddenly support about 300 tons of extra weight in a very short amount of time. As for the testing of these systems, we saw a lot of rapid closing tests where the arms would simulate closing around the booster as it came down for a landing. In order to actually test such booster-chopstick interaction, SpaceX also built a test tank, B-14.1, which was a scaled-down version of a booster methane tank. With this little fella at Pad A, teams performed dozens of slap tests to make sure that the arms closed at the right speed and to see what would happen to the booster when they were slapped by the arms. SpaceX also made another improvement to the arms by installing new shock-absorbing structures that are more durable and more resilient than the ones that they had before. Once again, all of this learning and all of the upgrades and changes worked like a charm during this flight, and Booster 12 was able to land back at the launch site right on the chopstick arms. It will never not look like sci-fi to me. In the case of the ship for Flight 5, Ship 30, based on learnings from Ship 29's melty ride through the atmosphere, it got a major overhaul of its heat shield in order to hopefully prevent large sections of it from melting during re-entry and to allow it to land right on target. This involved installing a backup ablative material underneath the tiles on large portions of the ship. This material would not be intended to be the main way for the ship to get protected from re-entry plasma. That's what the tiles are for. But it gave the vehicle a second line of defense and another chance of surviving re-entry in case some of the tiles were to break or fall off the ship. After removing the majority of the existing tiles and installing that backup layer, newer and tougher tiles were put in their place that, according to Elon, were meant to be less prone to cracking. Teams also installed additional tiles in the gap between the flaps and the body of the ship in order to reduce the chances of burn-through during re-entry. And all of these changes seem to work like a charm, because not only did the ship survive re-entry once again, but it also was able to land in the target landing zone. This is evidenced by the fact that we could see the ship from the nearby buoys that SpaceX had placed in the area in hopes of capturing the landing. It's true that one of the flaps still suffered some burn-through, but not anywhere near as dramatically as we saw on Ship 29. And this type of issue may not be a thing in the near future, which we'll talk about in a few minutes. So as you can see, each flight has gotten progressively better and better. SpaceX has learned a whole lot every time they've flown, and they've been racking up success after success along the way. After all that learning, we're finally at the end of an era and the start of a new. As I mentioned at the beginning of the video, Flight 6 will be the last flight of the first generation of orbital ships. And while it might seem like this mission is going to be just more of the same, there are still a load of new and important things being tried out that will help with Starship's future development. Once again, just like Flight 5, SpaceX will attempt to catch the Super Heavy booster, which for this flight is Booster 13. But this time, the vehicle incorporates a bunch of hardware and software upgrades based on the data gathered on Flight 5 that will give it an even higher chance of success. Just a few weeks ago, we learned through a video Elon posted on X that Booster 12's landing came a second away from being aborted. So it's no surprise that, as SpaceX says on its website, quote, mission engineers also updated software controls and commit criteria for the booster's launch and return. I guess if SpaceX has learned anything over the past flights, it's that anything they can do to improve chances of success is probably worth it. And all that data from Booster 12 certainly helps. Additionally, SpaceX says that there are upgrades that will, quote, shorten the timeline to offload propellants from the booster following a successful catch, end quote. This is something crucial for the future of Starship, as being able to rapidly offload the booster and prepare for another launch is sort of the whole deal of rapid reusability. However, a lot of the really new and important stuff for this flight is happening with the ship. Since this is the last Block 1 ship, SpaceX is willing to risk losing it more than some of the recent tests. For starters, SpaceX is once again trying to relight a Raptor while in zero-G, which they haven't gotten to do on any flight yet. And they need to in order to move on to actual orbital trajectories and flying payloads. Given the experience from Flights 4 and 5, it definitely seems like they have Starship's attitude control nailed down, so now there's a higher chance of success this time around. Again, the relight test will be key for future flights, where the ship will actually go into orbit with a payload instead of just going on a suborbital trajectory into the ocean. Ship 31, the ship for this flight, also has a major change to its heat shield. During Flight 5, SpaceX flew a few tiles on the side of the vehicle that were covered in aluminum. According to SpaceX at the time, this was to see how hot some of those locations got as aluminum melts at the temperature that steel starts to weaken. Based on that data, SpaceX has now stripped heat shield tiles from the sides of the vehicle, and it says that these areas are the ones being studied for catch-enabling hardware on future vehicles. Elon and other SpaceX officials like Kathy Leaders have already said that SpaceX's goal is to catch a ship around the first half of next year. So it's no surprise that they're getting serious on testing this already. This is, once again, another key test for the future of Starship, because without being able to catch a ship, there's no fully reusable rocket. On top of stripping these tiles off the sides of the vehicle, SpaceX is still testing new materials, and we've observed ahead of launch that there are what appears to be missing tiles or tiles coated in some new materials. Hopefully, we'll learn more about that either during flight or afterwards. Another key test that SpaceX will be performing on Flight 6 relates to the control capabilities of the ship's aerodynamic flaps. SpaceX said that during the final phase of descent, so probably after the plasma phase of the landing, the ship will intentionally fly at a higher angle of attack to stress the limits of flap control. SpaceX hasn't said what exactly this data will be used for, but you know what I always say, more data, more better. One key change that will hopefully aid in gathering more data on this flight is also the time of launch. Instead of being right at sunrise, Starship is now launching in the afternoon, with the 30-minute window opening at 4 p.m. Central. That means that by the time it's wrapping up its flight and finishing up re-entry, it'll be in the daylight, and SpaceX will be able to better observe its descent and take a look at all of the tiles and anything else they want to observe. So there you have it. That's a lot that's in store for Flight 6, even without a booster catch. While we've seen a whole lot of success lately, it's always worth keeping in mind how challenging reaching this point has been. There will undoubtedly be occasional setbacks along the way, but that's just how things go. This is something that SpaceX might have learned this year too. Even after hundreds of successful flights, you can still have a failure. You can probably guess that I'm referring to Falcon 9 here. So what's next? Well, in the future, there are still a lot more challenges ahead, and hopefully with the debut of Block 2, a bunch of these will be simplified. We'll have a much more in-depth video about the myriad of changes coming up, but it's still worth mentioning the major changes that will be key for Starship's future. For example, the ship's forward flaps have been famously moved slightly leewards, which means the gap between the body of the vehicle and the flap will no longer be in the way of the plasma flow during re-entry. That will hopefully solve a lot of the headaches that they've been having trying to keep the flaps intact during re-entry. The next version of the ship also includes the newest version of the heat shield tiles that should be more durable and stay on better, etc., etc. There have also been a lot of new tiles that are smaller installed in some of the areas where barrel sections have been welded together, which tends to be where they use glue instead of pins to attach the tiles to the vehicle. Another huge change is the size of the vehicle and its tanks. Starship Block 2 is only 1 ring taller, but it has larger propellant capacity that will make it meet Starship's goal of launching 100 tons to low Earth orbit. This was perhaps one of the main problems that SpaceX had with the previous version from an operational standpoint. They could have tried going to orbit and deploying Starlinks with the early ships, but they weren't as capable, and as we've outlined in this video, SpaceX was more interested in demonstrating the recovery of the ship rather than prioritizing deploying payloads. With this upgraded performance and Starship's landing from orbit already demonstrated, SpaceX will now be able to carry out flights with actual payloads on board. As we've seen, Flight 6 will feature an in-space relight of the Raptor engine, and if that's successful, perhaps SpaceX can go on and actually orbit one of their test flights of Block 2 ship. We've already seen in the last month or so that SpaceX is preparing the paperwork that will allow these types of flights. Right before Flight 5, the company requested a permit with the Federal Communications Commission to launch and operate the larger version 3 Starlink satellites that will be flying on Starship. Normally, this type of paperwork takes anywhere from a few months to a year. So I wouldn't be surprised if in 2025 we start seeing launches of Starlink making use of Block 2's upgraded performance. SpaceX will probably be very busy next year testing the ship in orbit, getting more experience out of it, and learning how to operate it for long periods of time. This type of testing will be key to perform one of the major milestones slated for 2025, which will be the ship-to-ship transfer of propellants. This will be a key test. not just for SpaceX in support of NASA's Artemis program and landing the next humans on the moon, but it'll also make going to Mars a lot more real and a lot more within reach. It's not a surprise that with all the key goals for next year, that SpaceX is wanting to launch up to 25 Starship missions in 2025. So 25 in 2025. Nice way to remember that. In order to do all of that, SpaceX will be making use of the nearly completed 1 million square foot Star Factory building, which will be churning out vehicles left, right, and center. We also hope to see the new version of the booster coming out of that factory as well next year, which should finish the transition to the next version of Starship. And did I mention we're also halfway through building an entire new launch pad? Oh yeah, hopefully with all that, we're gonna see a whole lot more activity in the Starship program in the near future. And this is not even mentioning all of the developments at the Cape, the development of the human landing system for NASA, and a whole bunch of other things coming down the pipe as well. I hope you follow along with us here at NSF. The future couldn't be any more exciting, and we'll all be covering this as best we can live right here as it happens. So here's to a successful 6th flight of Starship. Hopefully I'll see some of y'all out here during this one. I've been Jack Beyer for NSF, and as always, don't forget, be excellent to each other.